Hello friends, today we are going to discuss about power MOSFETs. So friends, as we discussed in the earlier lectures, what a MOSFET is, and we discussed about power diode and power BJTs. So we came to a conclusion that whenever we want to convert a semiconductor device to a power semiconductor device, that means we want to make any semiconductor device withstand a very high value of current and a very high value of voltages. So this can be done with an overdoping. So overdoping, as we already experienced in the earlier lectures, overdoping is introducing an extra doped n electrons so that the width of the carrier charge particles increases. As a consequence, the space charge carrier region increases. That's the only. So because of overdoping, we are introducing extra n region to the same junction so that the width of the space charge carrier region increases, as a consequence of which the semiconductor device gets converted to power semiconductor devices. That's the only reason that power semiconductor device is capable enough of withstanding excessive amount of current and a very high value of the voltage level. So here, what a power MOSFET does is, the function of a power MOSFET is the same as MOSFET, but the power MOSFET is designed in such a way it can withstand a very high value of current and a very high value of voltage. So friends, let's now talk about some basic qualities or the basic criterias of power MOSFET. So first characteristics of a power MOSFET would be as I mentioned earlier, a power MOSFET is capable of handling high voltage and high current values. Number two would be, a power MOSFET is designed in such a way it is capable of operating in a very high frequency application. So if a power semiconductor is able to operate in a very high frequency, that means that power semiconductor must be very fast. So the third point would be the response of that power semiconductor device, or here the response of power MOSFET is very high or very fast. So there is a fast response. Now friends, let's say there are three basic criteria of a power MOSFET, as you can see here. The first would be capable of handling high voltage and high current, high frequency application, and very fast response. Now let's talk about different examples of power MOSFET. So there are various type of power MOSFETs, friends. So some of them I'm naming here. Number one would be vertical diffused metal oxide semiconductor, and number two would be double diffused metal oxide semiconductor, trench metal oxide semiconductor, and etc. So friends, if you all can see this kind of power MOSFET, here the doping level is extremely high. That's the only reason. This is capable of handling extremely high value of electric current and electric voltage. So friends, as I already given you a very brief about the construction principle of power MOSFET, now let's talk about the real construction and working principle of power MOSFET in detail. So friends, if you can see in this figure here, this shows how the power MOSFET is being constructed. Let's say this terminal here is the gate terminal. This would be the entire region here, would be the source terminal, and this would be drain terminal. and this is completely metal, and this entire portion would be completely metal. So this is the drain, this is the source, this is the gate, and this portion is completely metal, and this portion is completely metal as well. Now friends, if you can see here there is the N minus substrate which came because of overdoping and excessive amount of electron. That's the only reason the space charge region, which is this, is increasing. So this entire device is capable enough of handling extremely high voltage and extremely high current. Now this region here is an intrinsic region. So the entire region here is the channel, and through this channel the electron flows, which makes the device conducting electricity with a small amount of gate voltage applied, as we already have seen in the MOSFET application in the BJT principles. Now friends, this is the channel, and this is a N plus region, this is a P plus region, and this portion is the gate. So the basic working principle of a power MOSFET is whenever we are applying a voltage to the gate terminal and the entire power MOSFET is connected with an external voltage, the condition would be applying a voltage signal to the gate terminal makes the entire power MOSFET conducting very high amount of electric current, and by withdrawing the same gate signal, the entire power MOSFET can withstand extremely high voltage. So that is the only criteria which makes a MOSFET a power MOSFET. So the entire diagram is mentioned here, how it is being constructed. Now friends, as you see here, the space charge region is increased because of the fact that there is an N minus substrate and N minus intrinsic layer. That's the only reason the entire space charge region has a very wider width, and this is the only reason why the entire device or entire power semiconductor device is capable enough of handling extremely high amount of voltage and extremely high amount of current. Now friends, let's talk about different criteria. For example, how the drain source resistances varies with junction temperature and the drain source resistances varies with electric current. So friends, let's talk about the effect of the drain source resistances with respect to the electric current. So let's say friends, ID be the drain current, which I am taking in the x-axis. So friends, RDS be the drain source resistances. As you can see, the drain source resistance varies non-linearly with the drain current, which is ID. So whenever the drain current is 0, there is a specific value of drain source resistance. As we are increasing the drain current, the drain source resistance is increasing in a non-linear way. Now friends, let's see how the drain source resistance varies with the junction temperature. Let Tj be the junction temperature, which I have taken in the x-axis, and RDS be the drain source resistance. Now, the drain source resistance varies in this way with the junction temperature. So here you can see friend, it is pretty much similar to the drain source resistance with respect to the drain current. However, in case of temperature versus drain source resistance, an absolutely non-linear curve. So this is how the junction temperature varies, or the drain source resistance varies with the junction temperature. In the same graph, the drain source resistance versus the junction temperature is represented here, but this is for the on condition. As you can see here friend, this graph represents how the drain source resistance varies with the drain current when the device is on. So friends, to summarize, we discussed about the construction of power MOSFET, the working principle of power MOSFET, and how the drain source resistance varies with the drain current and how the drain source resistance varies with junction temperature. So thank you so much friends for watching this video. Please subscribe to Ekeeda and stay tuned with Ekeeda. Thank you so much.